question A asks us to find the v in terms of r and c. Since we know t is the period for one rotation, then we could just use that as our time. And we know that the radius, or that the distance, sorry, would be equal to the circumference. I guess we could see for that. But we know the circumference is equal to 2 pi r. So we could just hit v, which is equal to dt, as v is equal to 2 pi r over t. And that would be our tangential speed for okay. R b, after to find the tangential speed v in terms of lt and theta. So we know that, as we did before, that speed is equal to the distance over the time, and that we can find the distance by finding the circumference, which is d is equal to 2 pi r. But since we want to find this in terms of lt and theta, what we could do is we know that r is equal to L sine theta, because r is the opposite of the theta, and this L is the hypotenuse. And so we could do what was done before, and we can make it so v is equal to d over t, and since d is equal to 2 pi r, we just have to plug in and substitute and put 2 pi L sine theta over t, which is our period. We are now doing part C, which is asking to prove this expression here, v is equal to the square root of gr tan theta. So the first thing I'm going to do is realize that fc is equal to mv squared over r, and that fc is also equal to ftx, which is the force of detention of the x direction. So since we know that ft is equal to mg over cosine, because when finding this, mg is going down, so we need to find the amount of force that is going to be pulling it this direction, and that will be equal to our tension in that direction. So we derive that, and we put ft is equal to mg over cosine, since this would just be the same thing as fg over cosine, as this the mg is going down. It's the same thing as the ty, and ty is adjacent to theta, so it's adjacent over hypotenuse. So from there we can see that after we set fc is equal to ftx, we also know that ft times sine theta is the same thing as ftx, because ftx is the opposite of theta. From there, for our speed, we can just say that mv squared over r is going to be equal to ft sine theta, which is, in this case, we're going to plug this in, for mg over cosine theta, the sine theta. And we know that sine over cosine, or opposite over adjacent, is the same thing as tangent. So then we take mv squared over r, set it equal to mg tan theta. The m's on both sides cancel out, and we're left with v squared over r is equal to g tan theta, which then, using algebra, we get r on the opposite side by multiplying both sides, and we find the square root of that. So we get v is equal to gr tan theta, or radical of that. And that is how we derive that. moving on now to part D, it asks us find ft in terms of m, v, l, and theta. So first things first, we did out that fc, note that fc is equal to ft sine theta. That way we can isolate for ft. So divided by sine theta, we get fc over sine theta is equal to ft. We know that fc is equal to mv squared for r. V squared over r. So we can now substitute to make it so mv squared over r over sine theta is equal to f of t, sorry. And we substituted r for L sine theta because earlier we derived that r is equal to L sine theta as r is the opposite of L. So after doing that, our signs cancel out. We're left with mv squared over L is equal to ft. For part E, says find the period t in terms of this expression. Our first step is to find that period t would be equal to obviously be equal to the distance over v. So using past derived equations, which is this one, and then just set t equal to 2 pi L sine theta over v. And the phi I decided to use was this one, since we derived that v is equal to radical gr tan theta. I simply input that in the bottom. And we find that t is equal to 2 pi L sine theta over the square root of gr tan theta. From there, took t, and after setting it again, I put the same equation. I separated tangent into sine over cosine. And cut the gr, 2 pi L sine theta. And the cosine goes up to the top. And the signs cancel out. Just cosine. So you get t is equal to 2 pi L cosine theta over gr. From there, this is where I stopped. I can't find the rest. For question F, we are given that mass is equal to 5 kilograms, length of the string is 4 meters, and the theta is equal to 30 degrees, and we are looking for dV. Since I have derived this from C, that V is equal to square root of gr tan theta, we can now use that same equation in order to find V. So V is equal to gr, which r we found earlier is equal to L sine theta, so it is equal to 4 sine 30 degrees times tan theta. And since tan is equal to, the theta is equal to 30, you can just plug that in, and we just find the square root. We now just need to plug in our numbers. So 4 sine 30 is equal to 2, and tan 30 is equal to 0.57. And then after after solving, get v is equal to 11.32 meters per second. Alright, now question G is asking us to find what FT is. What FT is using the same numbers from before, the mass of 5, the length of 4, and the theta of 30 degrees. And so earlier we derived that FC is equal to FT sine theta, and that we can just divide by sine theta, so FC over sine theta is equal to FT. So what I'm going to do here is, so that same question, first we're going to do is find FC, which is equal to mv squared over r, right? And so we know that earlier, I said before, derived r is equal to L sine theta. So we can just write this out as FC is equal to 5, 11.32. We found that earlier as well. Squared over L sine 30, sorry. 4 sine 30, which is also the same thing as 2. So after finding that, we just go 5 we find that the FC is 320.36 newtons. And then all we need now is to find sine theta. So we just put FC over sine theta, which is the same thing as 0.5 as the sine 30. So we put FT is equal to 320.36 divided by sine 30 degrees. 640.712 is FT. The last question is asking how different quantities would react if the speed is increased. For the first one, tension force, the tensional force would increase because, as we found beforehand, Ft, or the tension force, is equal to the Fc over sine theta. And since Fc is equal to mv squared over r, if everything else stays the same and the speed is increased, since it's on the numerator, our Fc will also increase, which, since our Ft is equal to our Fc over sine theta, if our Fc increases, then so does our Ft, meaning that it would increase. And for letter B, the radius should stay the same because the speed and the radius don't actually have anything to do with each other. As seen before, the R is not going to change. The R is equal to the length of the string times sine theta. So if the angle doesn't change and the length of the string doesn't change, then even if the speed changes, the R should stay the same. And for C, as we found before, as found previously, for C, the FSC shouldn't change because, it should increase. It should increase because FC is equal to mv squared over r. So if the R, as we just said, the R stays the same, the mass stays the same, but our V is increasing, then our FC naturally would also increase.